Welcome to Algebra 1 Honors. We're going to continue on in Chapter 7. This is Lesson 4, 7-4, Fractional Equations. Now, we just did 7-3, and it worked with fractions also, with what we call rational expressions or rational equations. And the only difference, the way they split these two sections up, is that in the previous section, 7-3, you had all numerical, only numerical denominators, i.e., the coefficients in front of your fractions were all numerical. They didn't have any variables in them. The difference in this section is that some of our denominators are going to have variables in them, which adds an additional complexity, if you will. Not a hard one, just one we have to remember. Whenever you see an equation or anything with fractions, in the back of your mind you ought to be thinking about a buyer beware clause. You know how when you buy a toy or something, or you buy a product that usually comes with cautions, buyer beware of this. Well, fractions should come with a tag attached that says, buyer beware, my denominator cannot ever be 0. Okay? So we always have to do one thing more when we have fractions in an equation, and that's to make sure we haven't made any denominators 0 when we get our final answers. Now, other than that, you're going to solve these equations, these fractional equations, the same way you did the ones in 7-3. Okay, and let's look at the first one. If we have 6 over x minus a fourth equals 8 over 2x. Okay, what we're going to do is find our least common denominator. Okay, so I've got an x, and then if I factor 4, I've got 2 times 2, and if I factor 2x, I've got 2 times x. So those are my three denominators factored. Okay, and remember, when we find least common denominator, we're taking the most. It's like playing Go Fish, but the person with the most of any card contributes it to the least common denominator. So the most x's anybody has is 1. This guy has none, but 1 beats none. So my least common denominator is going to have 1x in it. And let's see, this one has 2 2's, this one only has 1. So my least common denominator is going to have 2 2's in it. And when I simplify that, 2 times 2 is 4 times x. My least common denominator is 4x. Okay, now, then I'm going to do what I did in section 7-3. I'm going to take my least common denominator and multiply everything. Okay, everything by that least common denominator. Both sides. Don't forget to do both sides. That's an easy mistake to make. So I'm going to take my denominator, 4x, and multiply this. Okay, and then 4x here, and 4x here. Multiply every single term by my least common denominator. And I'm going to do some canceling. Okay, as I do that. So x goes into x once, and I'm left with just 4. 4 times 6, well, let's go back to the black marker here, gives us 24. Okay, and then here we're going to cancel 4 into 4 is once, into 4 is once, and I'm left with just x, and it's minus x. Okay, and over here, when I cancel, 2 goes into 2 once, 2 goes into 4 twice, x goes into x once, x goes into x once, and let's see, I'm left with 8 times 2 times 1, which is 16, and 1 on the bottom. Okay, so now I've got a very simple equation to solve. I'm going to add the x to both sides just so it's positive. So now I have 24 equals 16 plus x. Subtract 16 from both sides, and I get 8 equals x. Now, here's my buyer's beware clause, because I got fractions. I got to take that 8, and I got to make sure that in my original equation, there, that 8 didn't make any of my denominators 0. And the only place I really have to worry about that is where I have variables in the denominator. So if I put an 8 here, 6 eighths, that's not 0 in the denominator. If I put an 8 here, 2 times 8, that makes 16. That's not 0. So my 8 answer is correct here. Okay? Now, let's look at the next one. Okay, this one you should recognize as a proportion. So you already know one way to solve this. And we're going to have to check at the end to make sure we don't make this denominator 0. So we can't have x equal to 4. Okay? But we could cross multiply. That's one way we could solve this particular problem. Now, we're now going to look at another way to solve the problem. Our least common denominator here, we've got a 4 minus x, and we've got a 5. So we take 1 5 and 1 4 minus x, and that's our common denominator. Okay? So we're going to multiply this by our common denominator, and the other side. By our common denominator. Okay? And we're going to do some canceling. 4 minus x goes into that once and into that once, so those cancel. And I'm left with just 5 times 6 minus x here. And over here, the 5s cancel. And I'm left with just 3 times 4 minus x. Now, hopefully you're smart enough to see that if I had just solved this by cross-multiplying, I would get this right here. I would have eliminated a step. But another way to solve it. Now we distribute. We get 30 minus 5x equals 12 minus 3x. Add the 5x to both sides. We get 30 equals 12 plus 2x. Okay, subtract the 12 from both sides. We get 18 equals 2x. Divide both sides by 2. We get x equals 9. We got fractions, and one of them has a variable in the denominator. So buyer beware clause says I need to check. Well, it's a 9. 4 minus 9 doesn't give me a 0 here, so I'm okay. Gives me a negative 5. Okay? So you now have two ways to solve proportions. Let's look at another one. Okay, slightly more complicated. Same solution steps though. First we find our least common denominator. Well, x minus 4, that one's factored. I can't factor that one any further. This one though, x squared minus 16, I can factor into x minus 4 times x plus 4. It's the difference of perfect squares. And then x plus 4, well, can't factor that one any further. Now, least common denominator. Here's one x minus 4, here's another x minus 4, and this guy has none of them. 1 beats none. So I have 1 x minus 4. I have an x plus 4 here, and an x plus 4 here, and none here. So 1, the 1 that these guys have, beats the none. And that's my least common denominator. Now, then I'm going to take my least common denominator and multiply everything by that least common denominator. And now we're going to do some canceling. So I have an x minus 4 here. That'll cancel 1 with that x minus 4 there. And what I'm left with for that term is just 1 times x plus 4. Okay, plus, so I don't have to worry about distributing a minus sign, it's just a plus there. And then x minus 4 times x plus 4, that's what this factors into. All right? That's another name for that. So these cancel. And I'm left with a 1 on the bottom and just a 2 on the top, or just plus 2. Then over here, got an x plus 4 and an x plus 4 up here, so they're going to cancel. And I'm left with 3 times x minus 4. Now we have to simplify. X plus 4 plus 2 is x plus 6. Then distribute my 3 over here. I get 3x minus 12. Okay, let's add the 12 to both sides. Get x plus 18 equals 3x. Subtract an x from both sides. 18 equals 2x. Divide by 2, and our answer is x equals 9. Now, got fractions, have to do the buyer beware check. Take the 9. Let's see. 9 minus 4 is 5. That one's okay. 9 squared, that's 81. 81 minus 16 is 65. I believe that one's okay. And then 9 plus 3, that's 13. So I don't make any denominators 0. So 9 is a correct answer. Okay? Let's look at 2 more. Or 3 more, actually. Here's the next one. Okay? Now, we're going to find our least common denominator. To do that, we have to factor. In our least common denominator, we have an x minus 3, and we have an x minus 3 times an x plus 3. So our least common denominator is going to be one of these, x minus 3, times one of these, x plus 3. Okay? Now we're going to multiply everything, all of our terms, by our least common denominator. Okay, and do some canceling. X minus 3, those cancel, and I'm left over here with just x plus 3. Do some canceling over here. X minus 3, x minus 3, x plus 3, x plus 3, and I'm left with just 6. Okay, and then we do x, we subtract 3 from each side, and that gives us x is equal to 3. Now, buyer beware clause, because we got fractions with variables in the denominator. If I take my 3, right, and I put my 3 right there for the x, 3 minus 3 is 0. Ooh, that makes the denominator 0. That's a bad bet. I can't do that. So I have to throw out that answer because my buyer beware clause says no denominators can be 0. So I have no solutions to this equation. So I'd write no solution, or the 0 with a stripe through it, okay, or empty brackets. Okay? Now let's look at one or two last ones here. And these are kind of Miss Moran challenge problems for you, so we'll end on a strange one here. Let's see. Let me do this one. Icky looking problem, right? And our least common denominator is 987654321. So if we were just mechanically grinding our way along, we'd multiply both sides by 987654321. And that's okay, that'll end up, when we cancel, right? That'll end up that 3x equals 2x. Another way to look at this is if you have two fractions, and they have exactly the same denominator, okay, if I had, let's take an easier one like 3/4, and over here I had so many fourths. The only way if the denominators are exactly the same for the fractions to be equal is the numerators have to be exactly the same. So the value here has to be a 3, okay? So I don't really even have to worry about finding a common denominator there and multiplying, although that will work. Because I know this denominator and this denominator are exactly the same. So in order for these two fractions to be equal, my numerators have to be equal. And then let's see, I subtract 2x from both sides. And I get x equals 0. Now plug in 0 and make sure 0 is okay. If I put a 0 right here, I get 0 for my numerator. That's okay. Numerators can be 0. Then the value, if I have 0 of this kind of a piece of a pie, I have none. And put a 0 over here, same thing. It's okay to have 0 in the numerator, just not in the denominator. Okay, now let's look and see what happens if we flip these over. What if we had the following? Okay, now, I could make this problem really hard and do it the standard way, or I could stop and think for a minute. Your eyeballs should be telling you, your left eyeball or right eyeball should be looking over here. All right, your other eyeball is looking over here. Your eyeballs are powerful processors. They can really help you. And your eyeballs should be saying to each other, oh boy, I've got the same thing on the top. Both of my numerators are exactly the same, okay? Which means that in order for these two fractions to be equal, the only way they can be equal, all right, if I have two fractions and their numerators are equal, 4, like they're here, they're more complicated, but they're equal. And the only way that the two fractions can be equal is if their denominators are the same, okay? Well, let's see if we can make the denominators the same. So I can ignore the numerators because they're exactly the same. And I say 7x equals 5x. Okay, subtract 5x from each side. 7x equals 0. Divide by 7. X equals 0. What happens if I put in a 0? I put a 0 here. Oh dear. 7 times 0 gives me a 0 in the denominator. That's a no-no. That's a buyer beware clause. No, no, no. Put a 0 in over here, I'm going to get the same thing. I'm going to get a 0 there. So there's no solution to this one. My only point in showing you the last two problems is before you leap in and start crunching numbers or doing anything, which is what smart kids like to do, smart people like to just start solving the problem. Look before you leap. If your two numerators are exactly the same, all you have to worry about is can you find a number that's okay that makes the denominators the same. You only have to set the denominators equal to each other. You don't even have to worry about the numerators. If they're exactly the same, ignore them. Okay? Or vice versa, if the denominators happen to be exactly the same, no matter what they are, if they're exactly the same expression, then you only have to worry about the numerators. Okay? You don't have to cross multiply, you don't have to find the least common denominator.